the other, a difference in charge is established. If no salt bridge were used, this charge difference would prevent further flow of electrons. A salt bridge allows the flow of ions to maintain a balance in charge between the oxidation and reduction vessels while keeping the contents of each separate. So, the purpose of the salt bridge is to facilitate the movement of the anions from one half cell to another half cell. If no salt bridge were used, the charge difference would prevent further flow of electrons. A salt bridge allows the flow of ions to maintain a balance in charge between the oxidation and reduction vessels while keeping the contents of two half cells separate. With the charge difference balanced, electrons can flow once again and the reduction and oxidation reactions can proceed. So, this also helps for the proceeding of the reduction and the oxidation reactions. The value of a single electrode can not be measured experimentally because a half cell reaction cannot take place independently. One can measure only the half cell reactions by difference between the electrode potential of any two half cell reactions. If the cell potential and the electrode potential for one of the half cell reactions are known, the electrode potential of the other electrode can be calculated. Therefore, a standard hydrogen electrode is chosen and all other cell reactions are compared with this standard and a set of E naught values are obtained. So, we need a standard half cell and that standard half cell is hydrogen half cell. When a cell consisting of copper electrode immersed in a copper sulfate solution and a standard hydrogen electrode are connected to a voltmeter, the electromotive force of the cell is observed to be 0.34 volt. Oxidation occur at the standard hydrogen electrode which acts as the anode, whereas reduction occurs at the copper electrode which acts as the cathode. The electromotive force of the cell is found to be 0.34. So, here the copper 2 plus changes to copper and it is gaining the electrons. So, by gaining the electron, it means here reduction is taking place. The two half cell reactions are hydrogen gives 2 hydrogen plus ions in the aqueous and it loses the 2 electrons. These 2 electrons are accepted by the copper 2 plus ions and it forms the copper solid. The electromotive force of the cell is E naught. Electromotive force of the cell is equal to electromotive force of the reactant minus electromotive force of the left side. Electromotive force of the cell is E naught of copper 2 plus 2 copper. So, the electromotive force of obtained of the half cell, that is uh, 0 in the case of hydrogen, while the 0.34 is reading is observed in the voltmeter. So, the electromotive force of the copper solution is 0.34. The standard electrode potential of the copper is 0.34 volt. Cells are classified into two broad categories: primary cells and secondary cells. So, first, primary cells irreversibly within the limits practically transforms chemical energy to electrical energy. So, primary cells, they transform the chemical energy to the electrical energy, which is not irreversible. When the initial supply of reactant is exhausted, energy cannot be readily restored to the electrochemical cell by electrical means. Secondary cells can be recharged. So, the secondary cells which are used in our mobiles or in the laptops, so these cells can be recharged. That is, they can have their chemical reactions reversed by supplying electrical energy to the cells, restoring their original composition. Primary electrochemical cells can produce current immediately on assembly. Disposable cells are intended to be used once and discarded. Disposable primary cells cannot be reliably recharged. So, these primary electrochemical cells, they cannot be recharged. The chemical reactions are not easily reversible in the primary electrochemical cells. The active materials may not return to their original forms in the primary electrochemical cells. Common types of disposable cells include, or the primary cells is the zinc carbon cells or alkaline cells. These are the common examples of the primary electrochemical cells. So, electrochemical cells, they produce current immediately on assembling. They are used only once and discarded after using it. So, you have seen the cells used in the radio. So, that is the example of the primary electrochemical cells. When their life is over, then we discard the cells. Disposable primary cells cannot be reliably recharged. So, we cannot recharge these cells since the chemical reactions are not easily reversible and active material may not return to their original forms. So, the cells used in the transistors, that is the example of the primary electrochemical cells, or zinc carbon cells or alkaline cells. These are also examples of the primary electrochemical cells. Secondary electrochemical cells must be charged before use. They are usually assembled with active materials in the discharged state. They are usually assembled with active materials in the discarded state. Rechargeable electrochemical cells or secondary electrochemical cells can be recharged by applying electric current, which reverse the chemical reactions that occur during its use. The oldest form of rechargeable cell is the lead acid cell. Other portable rechargeable cells are nickel cadmium cells, nickel metal hydride cells, and lithium ion cells. The cells used in our laptop or in the mobiles, that are the example of the secondary electrochemical cells. So, indirect redox reaction, the transfer of electron is limited to very small distance, and therefore no useful electrical work could be obtained in these reactions. When the switch is in the opposition, no reactions takes place in either of the beakers and no current flows through the metallic wire. There is flow of electric current through the external circuit. Then the zinc rod loses its weight and copper plate gains the weight. The concentration of zinc sulfate solution increases and that of copper sulfate solution decreases. The solution in two beaker remain electrically neutral. Primary cells are those cells in which the chemical reaction occurs only once and cell becomes dead after some time and it cannot be used again. These batteries are used as source of DC power. So, there are some requirements of the primary cell. It must be convenient to use. The cost of discharge should be low. Standby power is desirable in the primary cell. Dry cell. It consists of a cylindrical zinc container that acts as an anode, a graphite rod placed in the center, but not touching the base, acts as cathode. The space between anode and cathode is packed with the paste of ammonium chloride and zinc chloride, and the graphite rod is surrounded by powdered permanganate and carbon as shown in the next figure. The cell is called dry cell because of the absence of any liquid phase. Even the electrolyte consists of ammonium chloride, zinc chloride and permanganate to which starch is added to make a thick paste which prevents leakage. The graphite rod is fitted with metal cap and the cylinder is sealed at the top with a pitch. The next slide shows the transistors which the transistor cells or the example of the primary cells which are used in today's transistors. So, center there is a graphite rod and there is a electrolyte solution of ammonium chloride is surrounding the graphite rod, and there is a zinc strip that is separated by the solution, dry solution. So, negative terminal is at the bottom while the positive terminal is at the top of carbons. So, with this I am going to finish the lecture on the electrochemicals cells. Thanks.